chain of fast food restaurants that operated 200 stores in 1999. If the rate of increase, look at this, guys, increase, it's going up. If the rate of increase is 8% annually, how many stores does the restaurant operate in 2007? Okay, so first of all, let's label our X and Y. Let's see what each one represents. So what is our input? Remember, input is always time. So we're talking about time specifically though. Years after what year, guys? Years after 1999. And what is the Y, guys? What are we talking about? We're talking about restaurants. Number of restaurants, correct? How many will we have in 2007? Well, let's set up a table. If we were to set up a table here, guys, let's go ahead and put a fun little table here, X and Y. If we were to say at year zero, well, what year is year zero? If no time has passed, well, isn't that 1999? And actually, let's set these up. After 1 year passes, isn't that 2000? When 2 years pass, isn't that 2002? Oops, not 2022, 2002. So if, in fact, I want 2007, where is 2007? Well, 1999 was 0. Isn't this number 8? That's what I'm looking for. Watch out for that, guys. So at year 0, originally, we had 200 stores. 200 stores. Now, what's going on every year? We said we have 100%, and every year it's increasing by 8%. So every year it's going up by, it's going up by 108% every year. Well, guys, can I multiply the 200 by 108%? No, we got to turn it into a decimal. How do I do that? Simple. With a calculator, put 108. If it's a percent, just divide by 100, and you will turn it into a decimal. So we're actually multiplying it by 1.08. So what's 200 times 1.08 times 200? That's going to give us 216. So that's what happened the first year. And then that year, it went another 108% up times 1.08%. And there you have it. We have 233.28 stores. Now, we could keep going over and over, but imagine if they asked you in 30 years, would you do this manually by hand? Heck no. So we have to create a formula to make life easier for us. And because we're multiplying over and over, you guessed it, it's a geometric sequence. So we have to find a formula for a geometric sequence. If you don't remember the formula, I'm hooking you up with the equation right here. So it's y equals the initial term times a common ratio to the power of x. So let's create this formula. So it's y equals, what was our first term? How many restaurants did we start with? We started with 200, right? Now, what are we multiplying over and over? We're multiplying 1.08 to the power of x. There you have it. That's the formula. And we want to know when the x, remember, years after 1999, when my x is on the 2007, which is the 8th year. So basically, replace the x with an 8. And you could do this by hand, or you can go with your good old friend, Mr. Desmos. And let's plug it in. No need to use the y, just use 200 times, or not even times. You can just put parentheses. 1.08, parentheses, to the power of 8. And there you have it, 370.8186. Now, let's use some common sense here, guys. Can you actually have 370.186 stores open? No. So using some common sense, you cannot get 371 because you don't have enough time. So you actually just have 370 stores open and one under construction, you could say. But again, that's how you do it. And basically, that's what you have to do. Create a formula, get all the things needed, and just plug them in.